Scene script. Have you ever wondered if you could travel back in time to witness history or leap into the future to see what's in store? Picture this, you're sitting in a machine, dialing back the years to meet Shakespeare in the flesh, or perhaps fast-forwarding to witness the marvels of technology yet to come. This is the enchanting allure of time travel, a concept that has captivated our imaginations for centuries. From H.G. Wells' The Time Machine to Back to the Future and even Doctor Who, time travel has been a popular motif in literature and media, often depicted as a device or portal that transports characters across the temporal landscape. But is time travel just a captivating narrative tool, or does it hold some basis in reality? To answer this, we must first understand what time is. It's a dimension, much like the three spatial dimensions we navigate daily. You might be sitting still right now, but you're always moving forward in time, every ticking second taking you further into the future. But what if we could control this movement, just like we control our movement in space? What if we could traverse this fourth dimension at will, moving backward and forward through time as easily as we move left and right in space? Physicists and philosophers have grappled with this question for decades. The laws of physics, as we currently understand them, don't explicitly forbid time travel. Einstein's theory of relativity, for instance, suggests that time can be bent and stretched, hinting at the possibility of time travel under specific conditions, but the practicalities and implications of such a feat remain a subject of intense debate and speculation. Time travel, a concept that has sparked curiosity and fascination, but is it just the stuff of science fiction, or could it be a scientific reality? As we delve deeper into this enigma, hold on to your seat, for this journey through time is sure to be a thrilling ride. To understand time travel, one must first comprehend the nature of time itself. In our everyday lives, we experience time as a constant, unchanging flow. But according to Albert Einstein's theory of relativity, this is not the case. Time, as it turns out, is not absolute but relative. It can be distorted, stretched, and squeezed by forces such as gravity and speed. Einstein's theory of relativity, published in the early 20th century, revolutionized our understanding of time. It posits that space and time are not separate entities, but intertwined in a four-dimensional fabric known as spacetime. This fabric is not rigid. It can be bent and warped by massive objects, creating what we know as gravity. Now, imagine a trampoline with a heavy ball in the middle. The ball creates a dent in the trampoline fabric, causing smaller balls to roll towards it. This is similar to how gravity works in space-time. Massive objects like the sun create a dent in the fabric of space-time, causing planets to orbit around them. But what does this have to do with time? Well, the theory of relativity also suggests that the presence of gravity can slow down time. This phenomenon, known as time dilation, has been confirmed by numerous experiments. For instance, atomic clocks at sea level run slightly slower than those at higher altitudes due to the stronger gravitational pull at sea level. In addition to gravity, speed can also affect the passage of time. According to Einstein's theory, as an object approaches the speed of light, time for that object slows down. This is why, theoretically, if you were to travel at near light speed in a spaceship and then return to Earth, you would find that more time has passed on Earth than for you. But here's the kicker. If time can be affected by gravity and speed, then it's not a fixed, unchanging entity. It can be stretched and squeezed, manipulated and molded. So if time can be stretched and squeezed, does that open a door to the possibility of time travel? The idea of traveling through time is not as simple as stepping into a machine and pushing a button. Time travel is a complex concept that involves theoretical methods such as wormholes and time dilation. Let's delve into these a bit more. Wormholes, often depicted in science fiction, are like shortcuts through space-time, connecting two distant points in the universe. Imagine folding a piece of paper and poking a hole through it. That's essentially what a wormhole does to the fabric of space-time. However, wormholes are purely theoretical at this point. Even if they do exist, we don't yet have the technology or understanding to manipulate them for time travel. Also, it's worth noting that wormholes might be incredibly unstable, collapsing instantly unless kept open by some form of exotic matter. Now let's talk about time dilation, a concept that comes from Einstein's theory of relativity. According to this theory, time can slow down or speed up depending on how fast you're moving relative to something else. If you've seen the movie Interstellar, you've seen a dramatized version of time dilation in action, where a few hours on a distant planet equal years back on Earth. These concepts may seem far-fetched, but they are based on our current understanding of physics. However, they also introduce a slew of complexities and paradoxes. For instance, if you could travel back in time and prevent your own birth, how would you have existed in the first place to make the trip back? This is known as the grandfather paradox, and it's just one of the many mind-bending conundrums that arise when we ponder time travel. Then there's the question of energy. Theoretical physicist Michio Kaku once suggested that to power a time machine, we might need something on the scale of a star's energy output. That's a lot of juice. The mechanics of time travel present a mind-boggling array of challenges and paradoxes that make it a tough nut to crack. While theoretical physics may allow for the possibility of time travel, what does that mean in the real world? Well, let's start with the energy requirements. Theoretical physicist Kip Thorne once proposed a wormhole time machine, but even he acknowledged that the energy needed would be equivalent to the mass energy of a star. That's right, we would need to convert an entire star into energy to power this machine. Now, I don't know about you, but I certainly don't have a spare star lying around, but let's say we did have that kind of energy. There's still the matter of the physical toll on the traveler. Time travel isn't like hopping on a plane. The forces involved would be immense. Even if we could create a stable wormhole, there's no guarantee a human could survive the journey. We're not built to withstand the kind of stress that comes with bending time and space. And yet, despite these seemingly insurmountable challenges, there are tantalizing hints that time manipulation may be possible. Some experiments have shown that particles can behave in ways that hint at the possibility of time travel. For instance, quantum entanglement, a phenomenon where particles become interconnected and affect each other no matter the distance, has been likened to time travel on a tiny scale. In another experiment, physicists managed to make light particles or photons return to their past states, essentially turning back time on a very small scale. While we're still light years away from sending a person back in time, these experiments show that the laws of physics may not be as rigid as we once thought. There's also the fascinating case of time dilation, as predicted by Einstein's theory of relativity. Astronauts aboard the International Space Station age slightly slower than people on Earth due to the effects of gravity on time. That's right. They're time travelers in a sense, albeit at a very slow pace. Despite the tantalizing hints, time travel remains a distant dream in practical terms. But who knows what the future holds? After all, the only constant in science is change. Imagine for a moment we did crack the code of time travel, what would be the implications? The answer to this question, my friends, is as complex as the concept of time travel itself. Let's start with the societal implications. Time travel, in essence, would allow us to revisit history or leap into the future. But this power could bring about a dramatic shift in the social order. Imagine the chaos if we could alter historical events, or the power imbalance if only a select few had access to time travel. It could create a world where the past, present, and future are all up for manipulation. Now, let's consider the ethical implications. If you could go back in time, would you prevent a disaster from happening, even if it meant changing the course of history? Would you visit your past self and give advice, or would that be considered cheating? These ethical dilemmas would need to be addressed before we could even begin to consider actual time travel. Then there's the reality of paradoxes. The grandfather paradox, for instance, is a classic example. If you could go back in time and accidentally kill your grandfather before your parent was born, would you cease to exist? Or would you create an alternate timeline where you never existed? These paradoxes pose significant challenges to the practicality of time travel. And finally, there are the profound questions that time travel raises about the nature of reality itself. If time is not linear, then what is it? Is our perception of time merely an illusion? If we can travel through time, does that mean we can also travel through different dimensions of reality? Time travel, while fascinating, brings forth a Pandora's box of implications that challenge our understanding of reality. It forces us to reconsider our place in the universe and the very fabric of existence. But until we crack the code of time travel, these questions remain a tantalizing mystery, captivating our minds and fueling our imaginations.